All right, here's the second half of 7-6 notes. We're still doing the same thing. We're identifying these 4 characteristics of the graphs. We have 4 examples, so we're just going to go through them. So let's go ahead and start with the amplitude. Again, I recommend in the beginning possibly labeling everything so that way it makes sense. So for the amplitude, it's a sine function. You're going to say A is 2. And then remember, if the A is greater than 1, then you're going to say vertical stretch. For the period, sorry about that. For the period, it is 2. So we do 2 pi over b. So if b is 2, we're just going to be left with a period of pi. So our period is pi. And then in reference to horizontal stretch and compression, use your b. So my b was 2. So 2 is greater than 1, so horizontal compression. Your phase shift will be this part here. Sorry, I'm all over the place today. So it's a positive, so I'm going to go the opposite. So I'm going to go left pi over 4. Your vertical shift will be dependent upon your k. Your k is a +3, so I'm going to go up 3. All right, let's try a tangent. We have not done a tangent yet. So for tangent, remember, there is no amplitude. So even though this is 1/3, it's not like a 1/3 for height purposes because our graph does not have a height. It goes up forever and ever. But we can use this 1/3 to say that the graph has vertical compression. And the way you would word it is you'd say vertical, and you want to state what the compression value is. Vertical compression of 1/3. Okay. And that's all we do for a tangent. The other thing that's different for tangent is your b value. So your b here is 4, but it's pi over 4 because the period is only pi long. So period is pi over 4. And again, this came from pi over b. And since b is 4, and then you would say that the 4 is greater than 1, so horizontal compression. Your phase shift, again, is your h value. So my h value here is a negative, so I'm going to go the opposite. So I'm going to go right, 2 pi over 3. And then my vertical shift is this value here, which is down 1. All right, we just have 2 more real quickly. So a sine and a cosine, and this time there's not as much going on, but everything's still here, it's just a little bit hidden. So for instance, amplitude would be this value of 1 here on both graphs, okay? So your amplitude is the number in front of your sine, which in this case there's nothing, we know it's 1, so amplitude is 1. And because it's not greater than or less than 1, that means this is the parent function. So because the a is equal to 1, it's the parent function, so there is no stretch or compression on this graph. And then same thing with the period. There is no number squeezed in the middle here, so your b is going to be 1. Same thing on this one. So if I do 2 pi over 1, that's just 2 pi. And again, that's because this is the parent function. So if your a and b are equal to 1, there's no shift or compression vertically or horizontally. The graph is the parent function, basically. The phase shift, though, so this graph is shifted a tiny bit. So you've got plus pi, so we're going to go the opposite and go left pi. And then the vertical shift here is a -1, so down 1. And then let's do that same thing for the cosine. So again, cosine has an amplitude of 1, so you're still going to tell me it's 1, but because it's the parent function, you won't have any kind of stretch or compression. And then same thing with the period. Since the period was equal to 1, you're just going to have 2 pi. Sorry, not the period. The b is equal to 1, so 2 pi over b is 2 pi over 1, which is just 2 pi. So anytime you are starting with the original 2 pi period, then you just know, again, no shifts, at least not vertically, no compressions and no stretches. The phase shift, again, what's in the parentheses? So I've got a negative pi over 2, so I'm going to go right, pi over 2. And then for my vertical shift, I've got a plus 1, so I'm going to go up 1. And that concludes the lesson as well as the chapter, so we will be moving on to probability for the following week.